So on the first one, the right-hand side is, you're doing a number 1. It's e to the minus x plus x squared. So you have an exponential term and a polynomial. So you have to account for each one of those for your particular solution. The particular solution is basically designed to the non-homogeneous term if you're in your differential equation, which is the right-hand side. Okay?
Yeah.
Right.
Yeah. How much basically difference between that and the
Right. So like, for example, e to the minus x will just have
this is
e to the minus x.
yeah, C minus X. No, E
You could call the coefficient whatever you want. And then the x squared will have the polynomial all the way from that power down to the constant. So if it's x squared, it will be bx squared plus cx plus d, just like I was showing you here. If it was an x cubed, it will be ax cubed plus bx squared plus cx plus d, all the way down to the constant. If it's an exponential, you know, you get the exponential. If it's a sine or cosine, the particular will have both the sine and the cosine, because you know the sine can generate derivatives of both sine and cosine, and so is the cosine, right? And then I was showing you that if you had like an exponential multiplied by sine, you're going to get the exponential multiplied by sine times some coefficient plus the exponential multiplied by cosine times some coefficient. So we will get into how to determine those coefficients in a bit, but in this case, it's just asking you to write the form. So this is doing it using the method of undetermined coefficients. We haven't solved for those coefficients yet, but we will get there. So now we're just writing the form. Okay. So like on number 2, I had a cosine, so I'll have a cosine plus b sine, or f sine, whatever you want to call the coefficient. So that's coming from the cosine, and then x squared e to the 2x will generate polynomials bx squared e to the 2x, each one multiplied by the exponential, down all the way down to the constant. So bx squared e to the 2x plus cx e to the 2x plus d. Because your differential equation will have 2 solutions to it: the complementary, which we were doing, and the particular. All this generates the particular. The general solution of the differential equation will be the sum of the complementary plus the particular.